Today we'll discuss with the Coulomb's law. Coulomb's law you have studied already in the 10th class, but here somewhat it will be more different. In the Coulomb's law, here Coulomb's law finds the force, electric force between two charged bodies Q1 and Q2, in which they are being separated by a distance r. So here Coulomb's law is used to determine the electrical force between the two charged bodies of different magnitudes separated by distance r. Now, what is the first of all we have to know what is the condition of Coulomb's law, or under what condition it is applicable, or you can say simply what is the limitation of it. Limitation is that first of all the charges has to be at rest, and and the charges should be point charge. These are the main two conditions for the validity of the Coulomb's law, that Coulomb's law is valid for the point charge and the charges has to be at rest, or you can say stationary charges. Now what is point charge? Point charge is that electric charge whose dimension or size is very small as compared to its effective distance. Suppose the charge dimension is very small, but it can create the field, or it can experience the force on any other charge to a great extent. So this is called effective distance. The effective distance is very large as compared to its size. Then it is called point charge. Now the what Coulomb's law state, or what is the statement? Statement is that force of attraction or repulsion between these two stationary point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. So if you combine these two, then F proportional to Q1 Q2 by R square, or F is equal to beta Q1 Q2 by R square. Now here beta is the constant of proportionality, and this constant of proportionality depends upon two factors. One is the nature of medium, and second one is the system of measurement. Now this value of beta depends upon the nature of medium and system of measurement. Nature of medium means either in vacuum or any other medium other than vacuum. Vacuum means absence of medium, and medium means which related to any other medium other than vacuum. Absence and presence of medium. System of measurement, either it is your CGS or SI. So in SI system and CGS system, the value of beta is different, and in vacuum or in medium the value of eta is also different. So keeping this to view, you can say that the constant of proportionality of the Coulomb's law depends upon the two factors. One is system of measurement and second thing is the nature of the medium. Now here you see this value of beta we'll study right now. Value of beta, first we'll go for the CGS system. Let us fix the system first. In the CGS system, beta is equal to 1 by k. So your equation becomes F is equal to, instead of beta you can put 1 by k q1 q2 by r square. Now this is the expression for the Coulomb's force in CGS system. Now we have already fixed the system CGS. Now I'll go to the medium. For vacuum, k is equal to 1. For other than vacuum, that is medium, k is not equal to 1. So what happens this when k is equal to 1? Now this above expression becomes F is equal to q1 q2 by r square, and for this F is equal to 1 by k q1 q2 by r square, because k is not equal to 1. Okay. Now we'll go for the most practical system, SI system. This is very important. Listen carefully. Now the original expression for the Coulomb's law is the F is equal to beta q1 q2 by r square. Now in SI system, this beta is equal to 1 by 4 pi epsilon. 1 by 4 pi epsilon. What? Where epsilon is the permittivity of medium. So what will be the expression? 1 by 4 pi epsilon F is equal to 1 by 4 pi epsilon q1 q2 by r square. Now this is the expression for the Coulomb's force in SI system. Then you go on, like your CG system, will go to the vacuum. In vacuum, epsilon is equal to epsilon naught. So what is epsilon naught? Epsilon naught is called permittivity of vacuum. I am telling here epsilon naught. Naught stands for no medium. That's why it is vacuum. So in SI system vacuum, F is equal to how much it will be? 1 by 4 pi epsilon naught q1 q2 by r square. While writing epsilon naught or epsilon, you should be very careful. Now so in medium, we'll take epsilon is equal to epsilon, you can say, or this F is equal to 1 by 4 pi epsilon q1 q2 by r square. q1 q2 by r square. Now we can write epsilon is equal to epsilon naught epsilon r. Epsilon r is equal to epsilon by epsilon naught. What is this? This is called relative permittivity of any medium is equal to permittivity of that medium divided by permittivity of vacuum. Permittivity of vacuum. How you are calculating the relative density of the substance. Relative density is equal to density of the substance by density of water. Likewise, keeping in view of the permittivity of vacuum, we can find out the relative permittivity. So we have from this relation epsilon r is equal to epsilon by epsilon naught, that gives rise to epsilon is equal to epsilon naught epsilon r. So in SI system and vacuum, in medium, SI system and medium, F is equal to 1 by 4 pi epsilon Q1 Q2 by R square is equal to 1 by 4 pi epsilon naught epsilon R Q1 Q2 by R square. Q1 Q2 by R square. Q1 Q2 by R square. So we can go for like this. For vacuum, epsilon r is equal to 1. For medium, epsilon r is not equal to 1. So in vacuum, F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square, since epsilon r is equal to 1. In medium, F is equal to 1 by 4 pi epsilon naught epsilon r Q1 Q2 by R square, or F is equal to 1 by 4 pi epsilon Q1 Q2 by R square. Very simple. If it is medium, just you put epsilon. If it is vacuum, you just put epsilon naught, and instead of epsilon you can put epsilon naught. Now this epsilon naught, or this is called permittivity of vacuum. Sometimes it is also called absolute permittivity. Now it has a standard value. And this epsilon naught has standard value 8.854 into 10 to the minus 12 SI units. And students will find out what is the unit of the epsilon naught. If you apply this formula, vacuum formula, F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. Now from this you can find out epsilon naught is equal to 1 by 4 pi F Q1 Q2 by R square. Now from this we can calculate epsilon naught is equal to, since 1 by 4 pi F Q1 Q2 by R square, epsilon naught is equal to Coulomb into Coulomb by Newton meter square. So this will be Coulomb square Newton minus 1 meter minus 2. This is the unit. So you got the value with unit of the epsilon naught, that 8.854 into 10 to the minus 12 Coulomb square Newton minus 1 meter minus 2. Now when you go for this When you go for this 1 by 4 pi epsilon naught, then this will be 1 by 4 into, instead of pi you can put 3.142, 8.854, 10 to the minus 12 Coulomb square, Newton minus 1, meter minus 2. On solving this, this 1 by 4 pi epsilon naught will come as together 9 into 10 to the 9 Newton meter square Coulomb minus 2. Then it will be reverse. Okay. So this is all about your value of beta, or the value of constant of proportionality. First of all, we know that the minimum value of epsilon is equal to epsilon naught, and always epsilon greater than epsilon naught. So epsilon r is equal to epsilon by epsilon naught, so that is always greater than 1. Epsilon r always greater than 1 for any medium, but epsilon r is equal to 1 for vacuum, and epsilon r never be less than 1, never be less than 1. Epsilon r never be less than 1, and epsilon r has no unit, as it is a pure ratio. Epsilon r is also called dielectric constant or specific inductive capacity. Epsilon r is equal to 1 for vacuum. This is 81 for water and 1.00048 for air, or approximately we are taking that it is almost 1 for air. This is all about your Coulomb's law. Thank you.